Now let's look at volumes when we have to rotate around the y-axis, and this is the problem that we're facing in this one. It says rotate y is equal to x squared around the y-axis. Now, like anything, if we go around the y-axis as opposed to the x-axis, like our area, we basically swap over and we're going to integrate with respect to y, but this time it's going to be pi x squared. So our x's and y's are swapped around. So notice when we've got pi x squared dy, that's what we're starting with. Our pi goes out the front because, again, it's constant. Now x squared is equal to y. So we just do a slight substitution there because x squared is equal to y. So we're just going to integrate y dy. Add 1 to the power, divide by the power, sub in 0 and 3. And what probably looks a little bit hard is actually works out rather nice. This time we've got y is equal to x squared minus 2 rotating about the y-axis from minus 1 to 2. So you can see minus 1 to 2. This area is rotating around. So instead of y equals x squared minus 2, let's get x squared equal to y plus 2. So pi x squared dy would become the y plus 2 dy. Because x squared is equal to y plus 2. Integrate both functions separately, and then substitute 2, substitute minus 1 in. Y equals x plus 2 this time. Around the y-axis means we have to change x to equal y plus 2. We're going to make it in terms of y. Make x our subject, and find in terms of y. So y minus 2 is going to be squared because it's got to be x squared. So if we square x, we square this side. Between minus 2 to 2, we do our substitution. We add 1 to the power, divide by the power, and do our substitution. And we're going to get that answer there. And this time we're going a semicircle between 1 to 2, rotated around the x-axis. Y equals square root of 4 minus x squared. So what we want is x squared by itself. So square both sides, and then do our add x squared on both this side, subtract y squared. X squared is equal to 4 minus y squared, so pi x squared dy becomes pi times 4 minus y squared dy. And our functions in terms of y, and we're rotating around the y-axis, so we're integrating with respect to y. Add 1 to the power, divide by the power, and do our substitution. Leave them all like that. That's just you can put it as a decimal if you like, but we can leave it in our exact terms. So just be careful when you're going around the y-axis that you do change your x to be in terms of y.